More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hi everyone, welcome back to Mathnasium Schoolhouse. Just want to make sure I can see your comments all here. I see a few of you already joining. Hi Ivan. Hello, hello. It's very nice to see familiar names, I should say. I was going to say familiar faces, but of course we're seeing each other, I guess, virtually, and so at most I can see your name, but it's very lovely to see you all joining each time. And just knowing that hopefully what's bringing you here is just a deep interest and fascination in math and all these different topics that you might have seen already or might have not. Hi, Sirkar. Yes, very nice. All right, maybe hello, Julian. I'll give a few more minutes or maybe just seconds for some more viewers to join us today, because today we have something fascinating we're going to explore, right? Every time we do these lessons, don't get me wrong, they are super interesting. There are a lot of math topics that you get to explore in class. And as I said, you might have already seen it, or maybe it's coming up for you. Hello from California, very nice. And today, what I wanted to do is just take a little bit of a different approach, which was to look at all of these things that we're learning in math. How can we really apply them? And how do they in the first place even apply to this real world that we're living in, right? And when everyone, our parents, our friends, our teachers tell us to study math because it's going to be important to us one day, if not already, where does it really apply in a career that we can choose? And so this is a really cool, fascinating way that we can see the application of math. And, I'm getting word that the connection might be lagging a bit, so hopefully it stabilizes soon. I'll just carry on, but today, as I said, we're going to be looking at cryptography. So it's a very cool fascination, and in fact, I wish I had learned a lot sooner about it, because the first time I really delved into cryptography myself was actually in my university when I was working towards my math degree, and I loved it. And as much as I thought that I loved calculus and algebra and studying all those, higher level math topics, when I came to actually cryptography and geometry in my third and fourth year of university, I fell in love. And I was just thinking, what were these professors doing to me? Why couldn't I have experienced this a lot earlier? So you guys are actually lucky. We're going to get to explore some very, very basic concepts in cryptography today. But my plan is, with some upcoming future lessons, we can explore a lot more challenging codes and whatnot to decode them and have fun and just really see the application of math within them. So if you guys had joined me on my Monday's lessons, I explored solving basic equations. And so we're going to use a little bit of that today towards the end. We're going to see how algebra actually fits in nicely into some cryptography topics and concepts. So hopefully you guys have a lot of fun. I want to take a different approach for today's lesson, and then I'm not going to leave you with any exercises per se in a packet that you can explore. But trust me, your closest Mathnasium center will be more than happy to explore a lot more codes with you and different ciphers. So definitely reach out after this. The summertime is a wonderful, perfect opportunity to do just that, right? To explore outside of some of those concepts you might have seen in the classroom. So let's get into it. You're going to hear some new terms today. I'm hearing that the internet is better. Good. I'm happy about that. Maybe the internet's just getting really excited for today's lesson, so it's just jumping for joy. Who knows? So we're going to look at some basics. We're going to look at a few ciphers. But before that, I want to just make sure that you guys are familiar with some of the terms I'll use. And just to answer the question, yes, these are recorded for playback, which is perfect. You guys can always go back and pause and play at a pace that works best for you. So ciphers and codes might be new words for you. I'll get into that in just a second. Encrypt, decrypt, you'll hear me use those words. And plain text and ciphertext. So I'll be using those throughout the lesson today and really get into what those mean in just a second. But ciphers and codes, if you are familiar with them, even just the slightest bit, we know that they protect information, right? And that's the whole idea behind wanting to code something, to create secret messages, and that's where a lot of the fun comes into play. Codes versus ciphers will do this by replacing words with symbols or other words, versus ciphers, which we'll really look at more in depth today, replace each letter in the message with a symbol or another letter. So more specific to every single letter in the message. And again, we'll see that played out in the ciphers that we deal with today. Why is this important though? Why explore this? Apart from it being fun. We know everything in math is fun. No argument there. But it's because it surrounds us, right? And ciphers and codes have gone a lot more complex than what they used to be. And we'll explore again the more basic ones to really get a solid foundation behind them all. But today, because of computers, we have the capabilities to do so much and to really create such complex coding systems that this mind up here will definitely not be able to work with it without the help of a computer. But at least we can gain an understanding of how the computers work, right? Which is also very fascinating. And that's what maybe might intrigue you after today's lesson to really explore cryptography more in depth. So I'm going to show you just a few that we won't get into detail today, but just to help you see that you're really surrounded by a bunch of codes everywhere, right? And you can have a lot of fun with them, with your friends, with your family members after today. And that's the task that I'll leave you with after today's lesson, is not necessarily codes of my own for you to decode, but to create your own and to send them out to friends. And if that's the best way that you can communicate with your friends right now, while we're stuck at home, it's definitely a very fun way to do so. So let's look at a few. Hello, Vivi. So let's look at a few. So there are some that are called, and I'm just going to pull up a bunch here that I have prepared. Some that are called a rail fence cipher. So this one's very nice to see just visually. So you can see the rail fence, the zigzag that's kind of appearing here. And I'm just going to use a marker to help myself out here. But let's say that you want to send the message, do not delay in escaping. The way that you could do it is use your letters, kind of going up and then down on each end here. So if my first word was do, you have D and then O. My next word was not, N-O-T. Then I have delay. You can start to see D-E-L-A-Y and so on. So that's the message that I'm trying to send, but the way that I would send it so that no one really intercepts and knows exactly what I'm trying to tell my friend, my sister, my teacher, anything like that, I would send this message here. How did I get that message? Just from this coding system that I used up here. I'll let you take a few seconds to take a look at that. And I apologize if it's hard to see. Maybe that's a bit easier. The message I want to send to my friend is, do not delay in escaping. How did I come up with sending this? Well, maybe you can already see if I just read left to right on that top row, D-N-T, D-N-T, E-A-I-E, and so on, all appear here. And then my second line is this second quote-unquote word that I'm sending to my friend, right? And I just need to make sure that my friend knows how to then decrypt this message, to really find out what it is that I'm actually trying to say to him or her. Okay, so that's a really cool one. That's something that you could even start to do right now if you want to send a message to your mom or anyone that's in the house with you. Okay, another one that, again, I just want to show you, but we won't necessarily work on today, is called a null cipher. So this one I'll maybe do some writing here on the board, but let's say I want to send a message, but I'm going to send a bunch of letters, combinations of letters that look like they have no meaning whatsoever, but hidden in between them is the message that I'm trying to send. So let's say, for example, I'm just going to do a really short one. B. See if you can figure this out, right? Math is all about trying to look at the information presented to you and trying to figure out what it's trying to say. So try to use that logic behind that to try to figure out the message I'm trying to send here. So this is one word, and then I'm going to write down here S, S, E, S, S, B, W. Okay. And then let me go maybe, let me go P, O, E, I, L, T, W, Q, S. There. I'll just do that. I don't want to write out the whole thing. So I'll stick with this. I'm going to tell you that there's only one word hidden here. And here, the way to kind of decode what I'm trying to hide here, it's just one word. It's coming from a longer phrase. I look at every third letter. So 1, 2, 3. That's the first letter. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the word here that I'm sending, let's say it was the beginning of a sentence, was meat. Okay. And then I would just create a bunch of other what look like words, but they really are nonsense. They don't read out to be any English language word that I'm familiar with, right? But this is the coding system that I would use. Look at every third letter, and that is a letter in the full phrase that I'm trying to send over to my friend. So that's one. And then you can do so much more. You might have heard of Morse code, right? That's something that uses a coding system that a lot of people are familiar with. Anagrams, and so on. And a few of them that we're going to use today aren't just going to stick with numbers and letters, but maybe even symbols. So let's say, for example, and we're not going to look at this one in detail, but it's very similar to one that we will look at. So this cipher here, for example, if I want to send a message that uses the letter A, the way that I would send that is to show which, let's say, square the A is located in. So it's located here, and which position it's in. So it's in the first one, not the second or the third. And if I wanted to send B, it would look similar, but the dot would be in the middle. And if I wanted to send C, it would be at the end, right? And so you can start to see we can code stuff without even looking at the English alphabet that we're so familiar with, right? We can start to use strange symbols, but they mean something to us, the person that's sending the code, okay? So go ahead and practice those already. Again, since these are recorded, you can always come back to these lessons, pause them, and oh, very cool. So I heard that one of you, Sirkar, learned Morse code in school. I'm actually quite jealous. I never got to learn that in school. Very nice. Yeah, so it could be a really, really fun application of math. And I really wish that we could explore it a lot more in the classroom, but there's just so many other cool things to learn. So let's leave it at that, and let's explore some in detail, the ones that I have prepared. So we're going to look at, very similar to the image one that I just showed you, I'm just going to refer to it as an image one for now, just because it's going to use these images. We're going to actually look at a Pigpen cipher that uses something, I'm going to say, familiar. Oh, what about the middle row? Very good question. Yeah, well, let me ask you that. What if I wanted to, let me ask you, send the letter N? That's a great question. How would I show that? Let me ask you that. Okay. So you can see here, it's located right in the middle, so I can just draw the whole rectangle around it. Right? So let's say I wanted to send N, would just be the middle dot because the N is right in the middle, but it's within a fully covered rectangle. I hope that answers your question. All right? All right, perfect. So then let's move on. So like I said, we're going to look at something similar. It's called the Pigpen cipher. So we're going to work on that. And then we'll get into some more complex ones as well. And then I promise to end off with one that uses algebra. So for those of you that saw my Monday lesson, we're going to work off of that. So let's carry on. So a Pigpen cipher, just a little bit behind that. The history itself is very mysterious. A lot of different groups invented ciphers very similar to it. And we saw one pretty much similar to it right now, around the same time. So we don't know exactly where it came from, but let's explore it here. So this is what we're going to use for our Pigpen cipher, okay? So I'm gonna present that to you here, and I think that's large enough for you to see. So if I want to send an A, very similar to what I saw before, I'm just going to show this corner here. I don't have to deal with the dots because there's only an A in this little cell here. B would look like this. I don't want to draw necessarily on it, but you can see the outline that I'm making with my marker. C, E would be a full square, and so on. So that would be A all the way to I. Okay. If I jump here to J all the way through R, I'm using the same images, but here's where I start to incorporate the dots. Okay. We'll see this applied in just a second. We'll actually work through one together. S, T, U, V, I'm using diagonal lines. Very similarly for W, X, Y, Z, I'm using diagonal lines but with a dot. All right. And this is just specific to this Pigpen cipher, so if you really want to challenge yourself, go ahead after today and incorporate different letters for yourself within these cells or within these diagonal lines as well. Right? So it doesn't have to necessarily go in the order that it's being presented here to you. I could decide to have B, D, G, X, Y, and so on. And that just complicates the code even more, right? Which is exactly what we want to do, so no one intercepts our message that we're sending to our friend. All right, so let's take a look at some exercises. So I'm just going to draw one on my whiteboard here. So I'm going to challenge you guys to tell me, and I'll leave this maybe on the side here. Tell me how I would encrypt F. Let's do F, S, and let's do Q. So I'll let you take a few seconds to figure that out. How would I encrypt that? And then we'll work through a whole word. What do you think? And I understand it'll be hard for you to write this in the comments, so maybe you can show me a thumbs up if you think that you've got it. This is where it'd be really helpful for you to have a sheet of paper in front of you, or just kind of think about it. And if you're thinking, you know what, Sandra, it's super easy, I see it right on the left side, yeah, that's exactly right. So if I want to look at F, maybe I'll help you out with this one here. I'm looking for F on my cipher here. I find F, and I know that the outline I have to draw looks almost like it's a C constructed of just straight lines. That's a nice way to describe it. Okay. I'm just using blue to show you that that's the encrypted letter. So go ahead and try out the next two. So all that we're doing here is taking our English alphabet letters and replacing them with these symbols, or in this case, it kind of looks like they're shapes. Okay. Okay. So, okay, it looks like F was done. Very nice. So let's do S. I find S here. It looks like it's just almost a triangle without the base at the top here. Thank you for the thumbs up. Glad that you found some of these. And then Q. Where is my Q? I find it here. It's one of these shapes with a dot. So it almost looks like a square with no base and then a dot just at the top. Oh, I'm so glad that you're enjoying this very much. I know this is one of those honestly really, really fun math topics. I can see a lot of kids that maybe don't even enjoy math per se, the way that it's presented in a classroom. This can be a really great, engaging way for them to have fun with mathematics. So I'm glad that you're enjoying this. Okay. So we've looked at letters. Okay, cool. But we wanted to be able to take this and really send a full phrase, a full word, a full sentence, if not a full essay one day, to our friends or someone out there. Okay. So let's say I want to just say hello. So I'm going to remove this. So in black, I'll ask you, I'll give you the letters, right? So how would I send this over? How would I draw out these shapes to a friend? Well, I would look at each individual letter. And so once I do that, just to move us along, I'll help us out. So the H is going to look just like this, right? I find it right here. The E is right in the middle, and we know that that's just going to be a square. Two L's, so two of the same. I find it right here. So it looks like this corner with a dot. Dot. Almost looks like an L with a dot. And then the O is just almost what I called a C before, with straight lines and a dot. And there you go. Okay. Go ahead and try to do that with any other words. And again, challenge yourself to send a message to someone and tell them what cipher you're using, in this case, the Pigpen, and they have to maybe even research it on their own to try to figure out the message that you're sending. Okay? And we could actually do the opposite, right? What if our friend comes back to us and gives us a bunch of these symbols? So what if they sent me this, and I actually had to find out what it is that they're talking about. They're sending me a bunch of shapes with dots. I'm trying to think, okay, I know the English alphabet. None of these resemble any letters that I know. But then I think, okay, hold on. Maybe they listened to today's lesson and they're trying to send me a message here, right? So then I would work the opposite way. So this, I have to try to find this symbol on here. There's no dot, so I'm resorting to this corner here. And it looks like only the H has this. And I know that this is going to spell hello, but I could do the opposite. Okay. Awesome, very nice. So this one's pretty simple to use, and as I said, reach out to your nearest Mathnasium for more fun activities just like this. I know that the instructors who all of them just absolutely love math would be more than happy to do this with you, all right? Very cool, all right. So let's move on to another one. Let's move on to the Caesar cipher. And this one's a very, very popular one, right? As I said, these don't seem too difficult. It's a great introduction to cryptography, and nowadays messages can be encoded using such complex algorithms that you really need a computer to work through them. But this is a good way to understand what's happening behind the scenes. It's essentially this. So let me remove this and bring out two wheels. Now I really hope this displays nicely on my camera in just a second. But we're going to be looking at the Caesar cipher, as I said. And this was used, of course, it's named after Julius Caesar, and it was used to protect information for the Greek military. And I don't think that I mentioned this earlier, but ciphers and just using the coding system is essential nowadays. Probably the best example I could give you is in our banking systems, right? When you want to send money across, it's essential to have that coding in place. But earlier, back in the days, it used to be really, really helpful for armies to send messages to one another. And as I said, it's just a great way to send messages across when you had to walk, kilometers or miles, and you wanted to make sure that no one who found your message actually knew what was being sent. So very, very cool history behind it. I highly recommend to go after today and read a lot more on it. But we're going to look at now another one, which is called the Caesar cipher. So this one, let me just pull out my exercises here. So this one is a substitution cipher, okay? So we're going to use these two wheels. I'll show you in just a second. But we're going to make secret messages by replacing letters based on a rule. And this one has a specific rule in place. I'll explain. This one in particular replaces each letter with a letter 3 places away. And so I'll show you how this works. I'm going to take this larger wheel and place this smaller wheel on top. And instead of having the A with the A, as I said, we're going to replace with a letter 3 places away. So naturally I would have something here holding my wheel in place. I don't have that, that's fine. I'll just turn it for myself. So I'm going to turn it 3 places away. So 1, 2, 3, and so I have my A right under my D, and that's the way I'm going to stay right now for my Caesar cipher. But of course, if you want to challenge yourself, you can always make it a certain number of places away, not just 3. Okay? So the way that we're going to use this, and I'll put some exercises here for us, is we're going to encrypt some letters. So let's start very basic. I'm going to ask you to encrypt B, we'll do Y, and we will do S. And the way that you're going to read it, I'll help you out with the B first. Well, actually, let me show you how the A works, right? So I told you that the A is now a D. So if I wanted to send an A in my word, I would send a D instead. Okay? So try to use that. I hope that the wheel shows up nicely. Yeah, I think it's readable for you guys. So go ahead and tell me what I would replace my B, my Y, and my S with. So I want to encrypt using the Caesar cipher. You want that spelling? There you go. Okay, so just to help you out, I said the A would be a D now. The B right next to it would be an E. There we go. What about the Y? And this one you guys can help me out with. You can just type it into the comments. Ivan would like a shout out. There you go. Thank you, Ivan, for joining us. Okay. So what do you guys think? What would Y be replaced with? So if I look here, if I look for my Y in my inner wheel, I find it here, and it would be replaced with a B. And what about my S? I'm going to look for an S in my inner wheel, and I replace it with a V. So let's go back to the word hello, right? What if I wanted to send that? So I'm going to erase this here. I'm going to write hello in black. That's the message that I want to send. How would I send that over? Definitely not with an HELLO. Then the person could easily read that. I want to send it over with different letters using this cipher here, right? So let's see. What would my H now be? If I find my H on my inner wheel, it's now a K. If I do the same thing with the E in my inner wheel, I find an H. L, there's two L's. I replace that with two O's. And then the O itself, let's find that on the inner wheel. It's an R. All right. And you can send larger messages, longer messages. You can say, hello, how are you? I am great. Anything like that, right? And we can also do the same backwards, right? We can decrypt messages. So let's say instead I gave you, I'm going to give you, and I'll write this in blue, and I want you to decrypt it. I'm going to send you WUH DV XUH DZDLWV. Let's see if you guys can figure out some of these. So now we're just doing the opposite, right? We're decrypting the message, right? So I'm going to look for these letters on my outer wheel, right? And then try to write down then what they're represented with on the inner wheel. So I'll help you out with the first one. So I want to find W. So I found W on my outer wheel, and so I substitute it with a T. Maybe I'll just write that above here, T. And if I want to find out what my U represents, let me find U, it's towards the end. There's an R. And I just continue with that. H, there we go, E. And I'll help you out just because I'm going to cheat a little bit. I know the message here, just to speed us along. This is treasure. Okay. What is the bottom word here? Let's see what it starts with. I found D on my outer wheel. There's an A. Z or Z, I find here. There's a W. What could this possibly be? D I already know is A. L is an I. And then I know there's a T and an S. So it says treasure awaits. There we go, right? So you can see how we can encrypt and then decrypt. So we can both send a message out and then we can receive a message and find out what it's actually saying in a language that we understand, in this case being English. All right? Treasure chest, very close. That would have been a good guess if you had to guess just what the message was. Very nice. All right, there we go. And let's look at a third one before we kind of do what looks like a typical math that we're so used to. So let's look at, let me remove this. So that was the pig pen and the cipher. So now we're going to look at the Vigenère cipher. And this is going to be a little bit more difficult for you guys to see, but I do just want to, get you a little bit curious about this one, not necessarily to help me out. This is really, really difficult to see through the camera. So what I can do is share it after in the comments, or the best thing to do is to have a Mathnasium instructor alongside you when you're exploring these. And so reach out and see what other puzzles they can present you with at your nearest Mathnasium. So this involves a Vigenère square. The Vigenère cipher was invented by a Frenchman. That's why that word sounds so different. Vigenère. And in the 1500s, so this is really, really long time ago, when he was studying ciphers. So he kind of developed this one. All right. So let's look how we can encrypt or make secret messages and then do the opposite. How do we find out, how do we decrypt or turn secret messages that come our way into something that we're actually familiar with? So let's look at an example. Now, Vigenères are a bit different than what we saw in the previous two ciphers because we do have to replace each letter, right, with another letter, but it's based on some rule. So I'll show you an example. The best way to do this is to see this. So let's say I want to, again, use the word hello. This is a nice short word here. Okay. So we want to encrypt this message, but we need to be given some key to work with, right? Or what we can think of as a secret word or a phrase to then encrypt this. So our key is going to be the word summer. Summer's coming up, let's just use that, okay? So if our key is summer, your first step, your first task is to use those letters and just write the key underneath. Summer has more letters than hello, so I'm not gonna write out the whole word, but almost there. So underneath the word that I'm trying to encrypt, I'm going to start to write out my key. I didn't have enough letters in hello to finish the word summer. If hello had more letters, I would just keep on repeating the key as many times as I needed to pair each letter. Okay. Now that I have this, I'm going to use this Venetian square. So this one, you can see they start to get a lot more complicated. This would be a lot more difficult to figure out what the message is that is being sent. Okay. So the first step here, let me try to do my best to show you this on the camera, is to locate the first letter in green. So here's it would be the S in this case, in the top row here, and then the first letter of the word I'm trying to send over in the first column here. So if I'm trying to find, let's start with H, I find H down here, I find it right here, just remember that. And then I find S up here, and then I see where they intersect. So if I look at this row, it intersects with the column for S right where the letter Z is. And so that is the first letter of my encrypted message. And I can continue this, right? So again, I'm going to look for E down here. Let me write that down. And then I'm going to look for U. So I'm going to stop where the U would be. Right? This is where the column is. And I find a Y. And I just keep on going. So I'm going to cheat. I know what this is. ZYXXS. So that's the message that I would be sending. Right? So that's if I want to encrypt the message. And then if I want to decrypt it, hopefully you can already start to see it's always the opposite, right? So let's say I'm getting this message. Instead of looking for the letter on the left side first and then the top, I'm going to do the opposite. So let's say I got this message. Let's pretend I don't know what it says. I'm just going to write it at the top here. I apologize if I'm not seeing your comments. Okay. Yeah, they're getting a lot more complex. So if you're understanding it now, don't worry about it. It definitely takes a lot of practice to really get a hang of it. So let's say I did get this message. I know it says hello because I just worked on it, but let's say I don't know what it says, right? So let's say that I wanted to find out what it is. So the first thing that I'm going to do is use my key, which was summer. Maybe I can change the word for us. Yeah, let's change it. Let's say we actually want to find out what this is. So let's say I want the word, I want to find out what this is. Let's say it's this, okay? So, and let's say that my key is cipher. We know how to spell cipher. I'm just going to put that up here. That's my key. that you guys can see that. Yep. Okay. So that's my key. Remember, for this Venetian, we need a key every time we're working with it. So if I know this, I'm going to start to write it out. C-I-P-H. Okay. And then I start to look for those. So let's go about this again through our square. So on it, we're going to first locate the first letter of the key, which is the C. Okay. We're going to find it in the column. So C is right here. And then I go down until I find the V. Okay. So let's go here. This is where the V is, and so that's represented by the T. So that's the first letter of the word. Okay. And then I can carry on with that. So again, let's say I wanted to find the next letter. I look for I. So I find I right over here. I go down until I find the Q. Okay. I found the Q, and it's represented by the I here. And then I carry on with that. So let's do that a few more times. So I look for the P, and I go down until I find a B. That's represented by M. And then I'm going to cheat again. I know that the next one will be E, and so this word is actually time. Okay? But you can see a lot more effort in trying to figure it out when I get the secret message. Okay? Hopefully you find that interesting. I definitely do, and obviously when I was learning this in university, you can just build off of so much more math that you're learning, and they just get so much more complex. But there's something really fascinating about math when it gets so challenging, and when you experience all these puzzles, you almost get addicted to trying to figure them out, and that's what I was doing. I remember doing all of my assignments, just spending so much more time on my math assignments than anything else, because it just got so addictive trying to find out what it is that this message was that was encrypted. Of course, using higher level math, but nonetheless still trying to do what you guys are trying to do right over here. So hopefully that's definitely as interesting to you guys as it is to me. So now let's go back to just some, using some algebra. Right? Does the key repeat over and over? Yes, it does. Sorry, I'm just reading some of your comments here. So yes, the key will have to repeat. Okay, perfect. Okay, so let's look at one more. I'm going to remove this. We're not going to need any sheets right now. So let's say that I tell you my code is going to use this equation here. So C is equal to P plus 4. And again, this will rely on some knowledge of solving equations, but probably more so substituting and evaluating expressions or equations. Okay? So in this case, the C is going to be the number of the ciphertext. All right. Yes, that's true, Alexander. So it does look very much like a crossword or a word search, very similar to the approach that you would take. So C is going to be the number of the ciphertext letter in our alphabet, and P is going to be the number of the plain text. And what I mean by plain text, I printed out for us the plain text of the alphabet that we're used to. So I'm just going to present it here. So all that I have here are all the letters of the alphabet in the blue rows here, and the numbers represented by each. So A, if I just start counting the letters of the alphabet, A is of course 1, B is of course 2, C is 3, D is 4, and so on. And because there are 26 letters, Z or Z is 26. Okay, so I'm just going to keep this as a reference. I'll pull it up as needed. All right, so I'm going to stick with this here. And if I wanted to send a message to my friend, what I would be doing is using my knowledge of what each letter is represented by, what number is representing each number, and find out the new letter that I'll be using. So let's say, for example, we'll start with A. So if this is P, then C is now going to be equal to P plus 4. So let's say I take 1 plus 4, this will now be 5. 2 plus 4 will now be 6. Then I can see a pattern, 7, 8, 9, 10, 11, 12, and so on. So really I should be saying that P is equal to these numbers here. Okay? So It is T, okay. So let's say that I wanted to send a message. I would use then numbers to send that message instead in these cases, okay? And I can get a lot more complex with that. Let's say I wanted to build a more complex equation. Let's say I wanted to have 3p plus 1. So let me present you with a problem. What if I wanted to use this equation instead to decrypt my messages? What would it be if I wanted to find, let's say G. Let me ask you this. I want to encipher G. And then I'm going to give you another problem. Let's say I want to decipher T. What would I be using for these? You might need this key here. Let me leave that to the side up here. I'll let you take a few minutes to figure that out, or a few seconds to figure that out. So remember, if I want to encipher G, I want to convert it, this is the way that I think of it, is convert it into the coded form, right? And if I want to decipher, that's the opposite. That was the decryption that we were doing always at the second time that we were dealing with each of our ciphers. So we want to find the original letter of the alphabet if we were sent over a T or decoding it. So how would I find it? Well, let's approach it this way. I'll pull this up as needed. Let's approach it this way. I'm going to stick with the math, right? I'm very comfortable with math, so I'm going to stick with it this way. So if I want to encipher G, I want to then find C, okay? Because I know that this is my plain text, which is coming from here, and G is represented by 7. And I think someone already shared that with me. Yes, thank you, Sheldon. That's exactly right. So if it's represented, if the plain text value is a 7, then I get C is equal to 3 times 7 plus 1. Very nice. Hello, Vivi. I know that 3 times 7 is 21. Added one more, I get 22. Great job, Sheldon. And what if I wanted to do the opposite, right? So here I was looking for C. Here I'm looking for P. How would I find that? And this is where we have to solve some equations. Okay? So how would I find that? And the only thing that I have to know here is the ciphertext value of T. So how would I find that? Let's see if anyone can comment that. This is where it gets a little bit more complicated. It's always more complicated to get the coded message and try to figure out what it is that it's trying to say to us. Reversing that coding process. Okay. Subtract 1 as the first step. Very nice. Yes, you're undoing the operation as we did on Monday. Very good. I like that. And then divide by 3. Very nice. Exactly. Right? So if I want to find the P, that's exactly right. So I know that T has a value of 61. And I have to solve for P. And as you said, I'm going to subtract 1 and then divide by 3. Okay? So if I do that, so let's do that in green. 61 minus that 1 gives me 60. And if I divide that by 3, what does that give me for P? That would be 20. All right, perfect. I'm going to end it there. I know that this can get super complex and at times confusing, so I highly recommend that you reach out to your nearest Mathnasium. And I know that especially, over the summertime or even during the school year when you're kind of, ahead and maybe not so interested in what's going on in the classroom, or you're very familiar with it and you want to see what else you can do with math to have some fun with it, I know that they'd definitely be more than happy to present you with more of these puzzles. And these are just a handful that I showed you today, but it just gets more and more complex. And for those of you that maybe don't see the application of this to math, another great way to just see how cryptography relates to math is just behind some of the thought processes involved, right? So as I kept on saying, there are a lot of puzzles that you encounter in this, which is what math is all about, right? And it's a matter of being presented with the problems, struggling sometimes, but that's the whole fun of it, and persevering to try to find, how do I get the answer? What questions do I ask? What is the pattern that's occurring? What is it that I'm observing that I can kind of put together to decode what is being presented to me? I'm going to end it off there. Have a wonderful day, everybody. I hope I've left you at least the tiniest bit more interested in cryptography, if not a lot. And I hope that many of you will continue to explore the applications of mathematics all around us. We will see you all tomorrow. Thank you all for joining Mathnasium Schoolhouse.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.